Okay, so proportional and non-proportional notes. You can, if you need to, you can cut the top off of these. I want you guys to glue these in your INBs when you're done, because this is a good note page to look back on as we get through this unit. So we're going to do this front, this back, and then we'll look at a homework page for you guys. So proportional and non-proportional notes. Proportional, it's your normal line when x is 0. When x is 0 and the y is also 0. So in a table, 0, 0. In the graph, that's the origin. Y equals mx plus b when there is no b. So like we did yesterday, the proportional equations, y equals mx, no b, or plus 0 if b is 0. When the slope goes through the origin, 0, 0, or the graph, when the y-intercept is 0, like in an equation. So this is all proportional. So example, in this equation, y equals 2x plus 0 or y equals 2x, that would be a proportional relationship, a proportional equation. In a table, we can see that it's not proportional because, or we can see that it is proportional, I'm sorry, because we have an x value of 0 with a corresponding y value of 0. So that would be the origin. That would mean our line, if we were to draw this line like here, it's going to go through that origin. Okay, just kind of a review page here. Down at the bottom, non-proportional. So when it's non-proportional, when x is 0, but the y is not 0. So in a table or in a graph, when the y-intercept is not 0 in an equation. So when there is a b. When there's a b value. In word problems a lot of times, we'll get into this later, but in word problems a lot of times it'll say this will be like a fee or something added on in a word problem. So in an equation, y equals 3x minus 5, so this minus 5 or negative 5, that's what makes it non-proportional because there's that b value there. In a table, we have an x value of 0, but your y value is 1. So what that means is that would be your y-intercept. Okay, so that would be where you would start your graph. So in that case, it wouldn't be proportional because it wouldn't go through the origin. In a graph, same thing. Look at your y-intercept, or where it crosses the y-axis. Since it crosses way down here, then it's not proportional. It didn't go through the origin. It didn't split this in half. It went way down here. Okay, so let's look at some examples on the back. This first example 1, determine if the graph is proportional or non-proportional. So we look at this y value, or we look at this y-axis, and we see where our line is crossing through it. We can't see the whole graph, but this would be 0, 0. This would be your origin. So does it cross through the origin? No. So is it proportional or non-proportional? Non-proportional. Non-proportional because the slope line does not go through the origin. Basically, there is a b, or your y-intercept. This equation, y equals 0.75x, determine if the equation is proportional or non-proportional. Well, I don't have a b, or my b is 0, so it's going to be proportional because there is no b or y-intercept. You can shorten this if you need to. Sorry, I didn't realize it wasn't on the screen. You can shorten this if you need to. You can kind of make it make sense to you. These are your notes. These are going in your INBs, so I want it to make sense to you. If you have any questions, you can ask us. Example 3, determine if the table is proportional or non-proportional and why. Let's look and see. So we have an x value of 0 here, but then our y value is 3 instead of 0. So that's going to make it non-proportional. non-proportional because 0, 3. So that would mean there is a y value or b. Example 4, determine if the following equation is proportional or non-proportional and why. So we've got y equals 8.5x plus 3. We've got some extra. We've got a b. So it's going to be non-proportional. In this particular case, it's non-proportional because there is a y-intercept of 3. Example 5, determine if the graph is proportional or non-proportional and why. Well, we don't have any numbers that we can see. If this was a full 4-quadrant graph, you can see that it goes through the origin. It would keep on going. And it touches 0, 0, so it's going to be proportional. Proportional. The slope line goes through the origin, which is 0, 0. Not too hard, guys. You just need to know the difference. Example 6. Determine if the table is proportional or non-proportional and why. So let's look and see. For an x value, we have a 0. When our x is 0, our y is 5. So since we have a y value, it's non-proportional. Non-proportional. Because basically, if you were going to put this on the graph at 0, 5, you would go 0 spaces on the x-axis and you would just go up 5. So that would make your line go above the origin. It wouldn't go through the origin. Non-proportional because there is a y value of 5, or a b, y-intercept. Okay, when you finish that page, if you guys, you can pause here if you need to write this stuff down. When you finish that page, you guys are going to look at this homework page, proportional and non-proportional. It's two-sided. This side is pretty easy. You're just classifying each as proportional or non-proportional and explain why. I don't need a big, long story, just kind of like we did here. Just why. What makes it not proportional? Is there a b value? Is there not a b value? What is your y value? And on the front page, same kind of a deal. You're just, on this one, you're having to look at it gives you the equation, but it's more of a word problem. But you're really doing the same thing. You're just classifying proportional and non-proportional. When you get done with this, front and back, if you'll turn it into the box, and then you can go back to my Google Classroom, and there's a Quizlet over this stuff, so you can click on that Quizlet, play any of those games, or you can click on the game link that I put up.